Today we're going to be learning to use the distance formula to find the distance between two ordered pairs on a graph. So here's what the formula looks like. The D stands for distance, and it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's see what that means. First of all, you're going to start with two ordered pairs. Remember that x is the first number of an ordered pair and y is the second. Okay, so here, let's say we have the ordered pairs 3, 1, and 2, 4. If you look down here at the bottom of the graph, you notice that 3, 1 is right here, and 2, 4 is right here. So what we want to know is what is the distance between those two. So we're going to use this formula right here. So what we're going to do is we're going to take it, we're going to plug in the numbers. Okay, so first you have to realize that one of the ordered pairs is going to be the 1, x1 and y1, and the other ordered pair is going to be x2 and y2. So when we plug in those numbers, we're just going to plug them in. So the first thing you're going to do is you're going to look at the x's and you're going to subtract them in the first set of parentheses. So in the first set of parentheses, we're going to subtract, you could do 2 minus 3. It doesn't matter which order you do them in. Again, you could do it both ways. You could do 3 minus 2, or we could do 2 minus 3. We're going to do it this way. Make sure that you're going to square that. Then you're going to do the same thing with the y's, but you have to do them in the same order. So because we use the 2 first, when we subtract the y's, we're going to use the 4 first. So it's going to be 4 minus the other y, which was 1. So look here. We subtract the x's, 2 minus 3 in the first set of parentheses. We subtract the y's, 4 minus 1 in the second set of parentheses, and then we're going to square. Now let's talk about how we evaluate it. First step of evaluating is you have to do the parentheses. So we're going to evaluate parentheses first. We have to follow our order of operations. So inside of parentheses, we have 2 minus 3, which is negative 1, and we have 4 minus 1, which is 3. Now, according to order of operations, we would evaluate the exponent next. So we're going to do negative 1 squared, which is negative 1 times negative 1, which is a positive 1. Then we're going to do 3 squared, which is 3 times 3, which is 10. 3 times 3 is a 9. My brain was ahead of myself already. I'm sorry. Now, the next step is we add 1 plus 9, and we get 10, but it's still under the radical sign. It's still the square root of 10. And we don't want our answer to be a square root, so we're going to go ahead and finish it up by taking our calculator and figuring out what the square root of 10 would be to the nearest tenth, which happens to be, this one happens to be to the nearest hundredth, but I would be fine if you also rounded it to the nearest tenth. I would read the directions and follow what they say to do. So, again, here we had on the graph, here was 3, 1, here was 2, 4. We thought that this was 3.16, 3.2. Now, what we actually did was we found a hypotenuse of a triangle. Because when you have 2 points on a graph like this, you can create a right angle and have 2 legs. So this could be your A, and this can be your B. And if you look here at our A, it is 1, 2, 3 units long. So A is 3 units long. The other leg is 1 unit long. And we think that C, the hypotenuse, would be 3 2/10, something approximate. So we could check this using the Pythagoras theorem. So remember the Pythagoras theorem is a squared plus b squared equals c squared. So let's just check and see if that works out. We would do 3 squared plus 1 squared equals c squared. Well, that gives us 9 plus 1, which is exactly what a while ago we had under the radical sign. So we have the square root of 10, which is exactly what we had a while ago. So notice when you use the distance formula, all you're doing is you're figuring out the hypotenuse of a right triangle that you created from those 2 points. Okay, so let's try again. So here we have 2 ordered pairs. So remember that we're going to use our formula here. We're going to plug in numbers. So we're going to subtract the x's first. So 2 minus 2. 2 minus 2? There we go. 2 minus 2 squared. Now we have to subtract the y's. So we can do negative 7 minus a negative 1. So look right here, we're subtracting a negative. So we add the opposite or do our click, click. All of that is squared. Now, 2 minus 2 is 0, so we're going to have 0 squared. I'm not sure what order I did it here, but so we have 0 squared, all under the radical sign. And we have negative 7 plus 1, which is a negative 6 squared. Of course, 0 squared is 0. So we have 0 plus negative 6 times negative 6 is 36. So we have the distance being the square root of 36, which is, of course, 6. So we subtract the x's, square it. We add that to subtracting the y's, square it, and then take the square root. Let's try one more time. So we're going to subtract the x's. So I'm going to go, you could either go 3 minus a negative 2 or negative 2 minus 3. I'm going to do the negative 2 minus 3. I'm going to square it. Plus, now I'm going to subtract the y's in the same order. 9 minus a negative 3 and square it. So I took the x1, we took the first x, subtracted the other one, squared it, and then we subtracted the y's in the same order. So when we evaluate this, first thing we do is evaluate the parentheses. So what is negative 2 minus 3? If we add the opposite, that would be negative 5 squared. And if we add the opposite or click, click, we have 12 squared. Now we evaluate our exponents. So negative 5 times negative 5 is 25. And 12 times 12 is 144. When we add those two together, we get 169. And the square root of 169 happens to be 13. So the distance between those two is 13. Now, I would like to show you an example from your assignment today. So let me get out of this, pull this example up here. This is what some practice problems look like. It even has up here at the top, it reminds you what the equation is so that you can be reminded. So remember, we're going to subtract the x's first. So I'm going to do 0 minus a negative 10, and I'm going to square it. Now, because I did the 0 first, when I subtract the y's, I have to put 8 minus a negative 7 and square it. 0 minus, if we add the opposite, we would have 10 squared plus 15 squared. Now we're going to square both, and we would have 100 plus 225. When you add those together, you get 325. Then when you take the square root of 325, it is going to be approximately 18 3/100. Now notice I have 2 decimal places because I read the directions. Round the answer to 2 decimal places, which means to the nearest hundredths. So it always serves yourself well to read the directions and follow them. Okay, so let's just practice one more together. Okay, you're going to subtract the x's. So I'm going to go 1 minus 7, then I'm going to square it. I'm going to subtract the y's, 5 minus 9, and square it. Okay, so first I do the parentheses. 1 minus 7 would be a negative 6, and I'm going to square that. 5 minus 9 would be a negative 4, and I'm going to square that. Negative 6 times negative 6 is 36. Negative 4 times negative 4 is 16. When I add those two together, I get 52, and the square root of 52 is approximately 7 21/100ths units. So there's some more practices that you can do on this page, and the key is provided for you. So good luck with the distance formula.